All right, let's get started. This is the first computer I ever owned. I think I got it in junior high. And people really complain about like the MacBook keyboard and some of those things. You don't know bad keyboards. This was called a chiclet style keyboard. And that thing to the left of the keyboard, for those of you who are, were born in this millennium, this century, that is a cassette deck, and right? I know you've probably never seen one, but that's what it looks like. A few years later, I got this computer, hooked it up to a television. It had color, whereas the other one was black and white. And I sold that one and didn't have a computer for a while. And then Commodore introduced this, and it was pretty cheap. I bought it at Target. That was an amazing thing that you could buy a computer at Target. Played with that for a few years, and then eventually bought one of these. I didn't buy the first Mac. I didn't buy the 128K. My first one was a Mac Plus, a few years after the original Mac was introduced. But one of the common things about all of these computers is I never installed software on any of them. It's nice. Some of those first computers, the software was on these cassette tapes, and you put them in the cassette deck, and you typed load something, and it would load it, and then you type run, and it would run the program. But it wasn't stored anywhere except on that tape. Later we graduated to these things, floppy disks. Again, if you were born before this century, some of them they were about this big, and they were really thin and had some plastic in them. Does anybody remember this disk drive for the Commodore? That was a really expensive piece of junk. And then floppy disks kind of evolved. They got smaller and could hold more and more stuff. But still wasn't enough, because if you wanted to install something or wanted to use something like Microsoft Word, you still needed 5,000 floppies just to do it. In this case here, this was the disks that shipped with, I think, the Macintosh Plus. And the OS, you ran it right off the floppy, right? So you would boot from the floppy. And when you booted, there was also some applications on that same floppy, like Mac Write and Mac Paint and some of those things. And it was really cool because you would type a document in Mac Write, and then you'd want to save it. And you just had that one floppy drive, and you were running the OS off that. So it would spit out the OS disk, and you'd put your data disk in, and it would start writing your file, and about halfway through writing the file, it would decide, I need some more OS code. So it would spit the data disk out, and you would put the OS disk back in, and it would read some OS code for a while, spit that out, and you'd put the data floppy back in. It was really fun. So obviously they decided, that's probably not the best way to interact with computers, and so more and more manufacturers decided, okay, we're gonna put hard drives inside our computers. And my first hard drive was an external hard drive, SCSI hard drive. It was about this big, and I think it stored 10 gigabytes. No, megabytes. 10 megabytes. Megabytes! I was really excited. And as I mentioned, once we had these hard drives, the manufacturers decided, we can make our programs even bigger. And so when you wanted to install what would have been the equivalent of Office at that time, you'd get a bunch of floppies for Word and Excel and that sort of thing, and you'd put them in one at a time, and it would copy some files, and then it would put some more in. So Microsoft had to write a special installer program that you would run that would lead you through sticking all of those floppies in the right order so that it could copy the stuff. And that was a great time that they could show you a lot of ads. And kids are really excited about emojis. Well, we had them back then too. I mean, right? That guy, I don't understand that one. Actually, I don't understand half of those. I mean, don't light bulb forget to register your copy of Word to get pig, or maybe it's a piggy bank, free, what is that, a pirate? Product support. And then, is that a pile of cash? Special prices on future Word updates, and lots of dictionary information. I don't get it. But then I don't get emojis either. So. So this was one of the ideas where you had to have a special installer program to get this stuff onto your disk. And again, going back to the sort of the original Macintosh, a lot of software was just self-contained, right? So MacWrite came on a floppy disk, but I could drag that, if I had a hard drive, I could just drag MacWrite onto my hard drive, and that's how I installed MacWrite. I just copied it from one disk to another. And we see that even today on OS X, where you can drag an application from a disk image, to your hard drive. In this case, Firefox is trying to tell you drag it to your applications folder, but you really don't need to. Firefox will run just fine right off that disk image, or you could drag it to your desktop. I mean, does anybody support users that have 5,000 disk images of Firefox mounted and they're running it off of whatever the most recent one? But it runs fine, right? It's fine, there's no problem. But some vendors kind of pushed that concept a little bit, and they figured, well, if we can train users, if users can just copy the software by dragging it, maybe we can give them a picture here telling them to install our software. You just drag this folder into whatever that thing is. And as it turns out, it's not anything at all. That was just a picture, and there was like an explanation that you had to go find that plugins folder, and here's all the possible places it could be, and drag those there. And of course, that plugin wouldn't work if you put it in the wrong place. If you drug it to the desktop, it's not going to work. If you left it on the disk image, it's not going to work. So that's probably not the best way to tell people to install software. So that's really what they wanted you to do. And let's take that to an even more absurd place, and that is, what if this is how you installed Flash? Let's drag the Adobe Flash Player Install Manager into the Utilities folder, and then we'll drag the Flash Player Preferences pane into the Preferences pane folder. And here's 2 more files that you need to drag into the Internet Plugins folder. How many of you users would do that correctly? Right? And we want to keep Flash up to date. So what if they had to do this every time there was a new version of Flash? Flash has got an exploit. We've got to get these updated. Walk around and tell all your users to do this dragging. So this is why the package format was developed, because we needed a way to accurately get files from installation media onto the disks of the machines. And they needed to be not only in the right place, but they needed to have the right ownership and permissions and all that sort of thing, especially now in the days of Unix-like file systems. I mean, back in the OS 9 days, there was no such thing as permissions or owner. You owned everything, you had full permissions to everything, so that was easy and safe and a happier time for all. So let's talk a little bit about what a package is. At its core, a package is simply a convenient grouping or an archive of files and directories. And those files, that archive contains information about the location, kind, owner, group, and mode of each file and directory in that archive. Optionally, a package can also run scripts. That's the presentation. Thank you. Are there any questions? All right. Well, I mean, really, you're happy, so I could just walk out now. Now, today we're going to look, we only have, 70 minutes or so. There's a lot to cover. I'm probably going to go a little fast for people. Again, this is being recorded, so you can go back and play it at half speed later if you'd like to. But we're going to tear open packages. We're going to see what the internal of a package looks like. We're going to look at some of the Apple package tools that you get on every Mac that you can use to make packages. That third point is wrong. We're not going to look at GUI at all. We're only going to look at command line. And we're going to look a little bit at package scripting. We're going to spend a little time at the terminal as well. Okay, I'm going to switch to a different slide deck here. All right, so we're going to dive right into packages. Again, I'm going to repeat this several times because I think it's super important. Package is an archive of files and directories. Archive contains information about location, kind, owner, group, and mode. And I'm going to repeat that again. Location, kind, owner, group, and mode. Package may also optionally run some scripts. Out in the real world, you're going to find lots of different kinds of package formats. We're focusing on Apple package formats. There are other OSs have their own packaging formats. But within the Apple world, you'll find bundle style packages and flat packages. Does everybody know what a bundle is on OS X? Can somebody name me something that is a bundle on OS X that you work with every day that's not a package? Application. The vast majority of applications on OS X are bundles. And what a bundle in OS X is, it's just a special kind of directory. So it's actually a directory of files and folders, but the Finder presents it to you as though it were a single file. So you can tell if you're working with a bundle package, and this is one of the things that's in the downloads, so if you want to expand the disk image, or maybe it was a zip file, you'll see this inside there. If you right-click on it or control-click on it, you'll see a contextual menu that says Show Package Contents. And this is how you know that this is a bundle-style package, because it's really a directory. If you were working with it at the terminal, you could just CD inside this thing, because it's really a directory. And once we show the package contents, we can kind of dig down and we can see what the structure of this bundle-style package is. And one of the things we can look at is that info.plist. And I highlight it, hit space, and quick look shows me the contents of that info.plist. And it's got some stuff in there that we might want to know, like the CF bundle identifier. That's a unique name for this package. The short version string, that's the version of this package. Where does it install by default? It's installing to the root of the hard drive. You may see other locations in here, like library extensions or applications. And does this package require a restart after install? In this case, it does not. Yes?
Would you mind doing where it was the condition where it's the root of the hard drive?
Yeah, sure.
Thank you.
So IP or IF package flag default location is the location the package will be installed to by default. Sometimes the user can change that. They can pick another place. We're going to actually blast through the bundle style pretty fast, because in the real world you're not going to find very many of these anymore. The big place you still encounter bundle packages is anything that's output by Adobe's packaging tools, the AMI and Creative Cloud Packager. Their outputs are all bundle style. I really had a hard time finding an example bundle package. That's why this is some strange editor from I don't know where, Italy. So a couple other things inside this bundle package. There's the archive.bom. BOM stands for Bill of Materials. It's really just a list of what's in the package. We'll look at that in depth in a moment. The archive itself, think of that as just a zip file, a tar file, a stuff it archive if you're old like me, that all of the files have been compressed into an archive. Some packages will have resources directory that might contain foreign language translations of help text, icons, stuff like that. But more importantly, you will often find scripts inside that resources folder. And when I say that a package may optionally run some scripts, this is where they live. Bundle packages can have 6 different kinds of scripts. Pre-flight and post-flight will always run. Pre-install, post-install will run only if this is a brand new install, if no version of this package has ever been installed before. Pre-upgrade, post-upgrade runs if this is a upgrade, that there's already a receipt for an older version of this package and now you're running a newer version. I know that's a little complex, but that's what we have with bundles. There are also what are known as meta package or distribution packages, and those tend to wrap multiple packages into a single bigger package. You can still do the same thing with these where you can right-click and get their contents. And when you do, you might see something that looks like this. And you can see that there's some additional sub-packages inside this meta package. So the user can double-click a single meta package, this Monkey Tools package, but what they're really doing is installing these 4 sub-packages. And those sub-packages can be expanded, and they have a similar format to what we looked at earlier with that NE package, where we have the archive, the info plist, resources, that sort of thing. There's a distribution file at the top level, and that controls which packages are installed, what order they're installed in, may contain some additional installation logic. And it's an XML formatted file. And I know we all read XML like we read our Greek and our Latin. But there's some stuff in there that normal humans can parse. And we got the identifiers for the individual packages. We can see what version each of those individual packages are. We can see that this particular package requires a restart. And this is the sort of thing that controls what the user sees when they click the Customize button for a meta package. So here I'm seeing the 4 individual packages, and I can choose which ones I'm going to install. Far more common out there are flat packages. These were introduced in 10.5 Leopard, and they're called flat because instead of being a special kind of directory, they are a single file. So all the contents of that directory have been compressed into a zip archive, and I'm saying the word zip, but in my brain I'm seeing XIP, which is not the same as zip as ZIP. But it's a ZAR archive actually, but a single flat file that contains all of the stuff that we had seen before. These also come as individual component packages or combinations of multiple packages, which we can call distribution packages. So in the wild, though, you'll almost always encounter flat distribution packages, even if there's only a single package inside it. So again, in the stuff I had you download, if you had a chance, there's an AX something or another, and it's a driver for a USB to Ethernet dongle. And we can do the same thing where we right-click on the package, but you notice that there is no show package contents, because this isn't a directory that we can expand. And that's how we know that this is a flat package. So one way you can still dig into it and find out what's in there is to use the command line. And you can use the pkg util command and expand it. And so here what I'm doing is I'm expanding one of the packages on that disk image to the temp folder. And I like to use /tmp, the temp folder, for this sort of thing because the OS will clean it up automatically. I don't have to remember. So that's reason number 1. Reason number 2, it's not sitting on my desktop cluttering stuff up, so it's kind of out of sight, out of mind. But if you want to expand it out to the desktop, feel free to do that. Just, you can throw it away afterwards. This just lets me be lazy and let the OS clean it up for me later. But once I've expanded it, I can ask the OS to open it up in the Finder, and I can see contents. I can see there's still more packages in the sub-packages inside this. There's a distribution file, and there's a resources folder. So the contents are kind of similar to what we saw with a bundle-style package once we've expanded it. And once we have these sub-packages expanded, we find out that, yep, we can use the show package contents to dig into the folder. And we see that there's some similarities of the structure of the flat package once it's been expanded with the bundle package. And some things that correspond. The names are slightly different, but they're the same thing. Is bundle package has an archive.bom. The flat package has a file simply named BOM, or bill of materials. Archive is simply named payload in a flat package. the info plist, it's changed names. It's also changed formats, but it serves the same function. Scripts have moved from a resources folder to a folder simply called scripts, but they have similar, it's a similar type of layout once you know what you're looking for. So I mentioned that the package info file kind of replaces the info.plist. So let's take a look at what's inside package info. And we'll see, instead of it being a Apple plist formatted file, it's an XML file. So it's slightly different format, but we can still kind of get that same information out of it. There's the identifier. There's the version. The install location. So this one's not installing to the root of the drive. This is installing down to library extensions. And it requires a restart, which is really common when you're installing a hardware driver. You need a restart to activate it. And it even tells us what scripts are going to run. So about those scripts. So with a bundle package, I said there were 6 types of scripts that could run. With Flat, Apple's gotten rid of 4 of those. There's only a pre-install script and a post-install script. Those are the ones that are supported out of the box. A pre-install script could call other scripts. A post-install script could call other scripts. So you could actually have more than that in the package. But Apple, by default, will only run those 2. There's slight other differences in the organization. You'll notice that for a bundle package, there's a distribution.dist file, and then there's a packages folder that contains our subpackages. For Flat, they're all just at the top level. But again, not that different. And again, these subpackages also contain similar files to the bundle packages. So let's dig in a little bit more. We're going to look at one of those packages from the from the AX driver download. So we looked at, for the bundle packages and for Flat packages, I talked about this thing, a bill of materials file. So either archive.bom or BOM. And I told you that this was a list of file system items and metadata. You'd think, well, all I have to do is just open it up in a text editor or use cat and I can just read it. Well, no, it's in a special format. So if you want to read the contents of a BOM file, you have to use a special Apple tool. It's on all your machines, called LSBOM. And remember I said that an archive that's in the package contains information about the location, kind, owner group, and mode of each file and directory. That's where the location is stored, is in that BOM file. So if I use LSBOM to examine the contents of one of those BOM files, I'll see something like this. So let's look at a single line of that. And so we've got the name. So we're installing a kernel extension of some sort. And here's our owner group and mode. And this is in numeric format. So a 4 means it's a directory. If there was 10, it was a regular file. 12 is a symlink. You may see that in some of those. There's no symlinks in this particular package. And then, actually, let's go back. And is everybody familiar with like the 755 style of permissions? You know, so we know that this is read, write, and execute for the owner, and read and execute only for group and other. And then user and group. So this file is going to be owned by the 501 user. And what's group 20? Staff, right? This is a kernel extension. Does this strike anyone as a little odd? What? Shouldn't be 501. Does a Mac have is a Mac guaranteed to have a 501 user? No. So that's a little odd right there. Kernel extensions run as root because they've got hardware access. So should it be owned by a non-privileged user? And if it's staff, if staff has, is the group, so something's funky here. But we'll come back to that. Also in this BOM, we've got a file size and a checksum for each file. So let's go back to that 501/20 owner and group. I happen to know enough about kernel extensions to know that they have to be installed with root owner. They won't work if they're not installed with the owner root. So this strikes me that there's something wrong here. So I'm going to dig in here. I went back to that package info file and I see, okay, the install location is library extensions. So I can put that together with library extensions, and then I can see these relative paths. So I know that the file I'm looking for, if it's installed on my machine, is going to be at library extensions AX blah, 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 blah. So I can use the ls command, and I can see what's going on my machine, and it looks right. So the file, I ran that package, it installed a file on my machine, and its owner and group are what I expect, which is root and wheel. That's what I would expect. So that would be 0, 0 if I was looking at it numerically. But yet the bill of materials for the package tells me that it's going to install the file with 501 as the owner and 20 as the group. So how is it that the file on my disk has the correct expected ownership? Anybody have a guess? And scripts. Remember that a package may also optionally run some scripts. And it turns out that this package, if we look at it a little more carefully, there is a scripts folder, and there's a post-install script and a pre-install script. And so if we take a look at the contents of that post-install script, we see that here's a line that starts with sudo for some reason, but we'll pass over that for now. It's changing the ownership, chown, that's what chown is, and it's changing it to root and wheel. So what they've done is they've built a package that installs these files with the wrong owner and group, and then they run a script later to fix it. Anybody notice anything else that could be a problem here? It's okay if you don't. We'll look at this again later. Now remember that they could have built this archive with the correct owner and group. They didn't need to do that script because the archive can do that. And that's a very common failing I see in third-party packages is that they will use a post-flight script to do things that should have been done in the archive. I've seen post-flight scripts that copy files to the correct locations. Why didn't you just install them to the correct locations in the first place? Changing owner, group, and mode, why didn't you just install them with the correct owner, group, and mode in the first place? If the vendor can't get the package right, are they getting the software right? I don't know. So there's other ways you can get information about what's going on in a package. We used pkg util earlier to expand a flat package. Pkg util can do a lot of things, and we're going to look at more of them in a minute. You can just point it at a package and ask it, what are the files in the payloads? It won't give you all the information as far as owner, group, mode, all that sort of thing, but it'll give you a quick listing of all the files that are in the package. You'll see, now you're looking at this and probably going, hey, it's the same files twice. Remember that distribution package actually had 2 sub-packages, so it's actually showing me the contents of both of those sub-packages. And as it turns out, you're thinking, why does it have 2 packages inside? Let's look at the distribution file. And we dig through this. I don't know what all this stuff is, but down here, I see the really nice named choice ID choice 3 and choice ID choice 58. And one of them is a 10.9 to 10.11 driver, and one of them is a 10.6 to 10.8 driver. So what the manufacturer's done here is they have 2 different versions of this driver, but they've bundled it into a single package. And when you run the installer, it detects which OS you're running and installs the correct sub-package. So the user didn't have to know which is the correct one to install for the OS. The package itself figures it out. And that's good. So the vendor's done a good thing here, and they've done this correctly. So if you're following along and you want to try what you've learned today a little bit, we're going to do this quickly because, again, let's see, how much time do I have? 45 minutes. It's not too bad. If you downloaded that Adobe Reader package that in the materials, can you take a look at the contents of it and answer these questions? What are the component packages inside that distribution package? Which of those component packages include scripts? And what are the install locations for the component packages? That Adobe Reader DC package is a flat package, so you're probably going to have to use pkg util -- expand to expand it out so you can look inside it. So that would be the first hint I would give you if you want to go along and look at this. I'll give you a few seconds. And again, if the command line is not your thing and you don't want to follow along or you don't want to try it yourself at this time, that's perfectly okay. So one answer, or one way you might get the answer to this question, is we can do pkg util -- expand path to the package on that mounted disk image. I've expanded it to under the TMP folder, and then I list the contents of that folder, and I see 5 items that end in .pkg. So there's a ARM agent, a support package, reader services updater package, application package, and a browser package. That's a lot of packages. Another way I could have done it would be to simply grep for anything ending in .package. So now that we've got those component packages out of the bundle, or out of the distribution file, you actually could use the Finder at this point, or you could use the command line to answer this question, which is, which of those 5 component packages that are inside the distribution, which one of those contains scripts? And if anybody has the answer, raise your hand. See who's fast. Okay, I see one person. We'll give it a couple seconds here. I see people still trying to. They might be working on their email, but I see people typing. Or writing snarky things about me in Slack. So what you could do to discern, you found something as well. So out of the 5 packages, how many have scripts? 4, all right. Here would be a way to do it, right? So you could either use the Finder, or you could just look in the contents of each of these sub-packages, and I see that, oh, there's a scripts directory in 4 of them. So everything except the support package contains scripts. There's a lot of scripts if you actually dig in there, but we're not going to. And then what are the install locations for the component packages? Again, if you've expanded those component packages, what you're probably looking for is look at the distribution file for the meta package, and it will tell you the install locations for each of the packages. Or you could also look at the package info files inside each of the component packages. For example, let's just do the first one. Let's do the Adobe Reader, or the Reader Services Updater package. We could look inside that package info file. Oh. There we go. And we see the install location is, well, that's a weird install location. TMP web installer, that's weird. Didn't Greg say earlier that the stuff in TMP gets automatically deleted later? That's an odd place to install files, don't you think? If we look at all of them, okay, so we got the TMP web installer. That's a bit strange. Okay, the applications package installs to /applications. Okay, that makes sense. Okay, here we got another temp. Okay, that one makes sense. The browser plugin is installing to library internet plugins. And the support package installs into library application support. So those 2 packages that install into TMP, how can they possibly be doing anything useful if TMP is a temporary location that gets cleaned up automatically? Anybody have any ideas? Yes, of course, there's more scripts. So what, you'd have to actually dig into the script to take a look to see what it's doing. But they're obviously installing some files into TMP, and then the script is doing something with those files. It may be moving them to their final locations. It may be using them for other nefarious purposes. We actually don't know until we read the scripts. So that's not very friendly, but that's what you have to do if you're auditing these sorts of packages. All right. I'm going to switch another slide deck here. We're going to look a little bit more in depth of the various command line tools that Apple makes available for packaging. So we looked a little bit already at pkg util, and that's a general purpose tool for querying and manipulating flat packages. It has a lot of subcommands. We're not going to look at every single one of them, but some of the ones you might use. pkg util -- packages simply gives you a list of all the packages that have been installed on your machine. And if you do that on your own machine, you'll probably find it lists, a lot of stuff. So you might want to look for specific packages. And let's say I wanted to find out, are there any receipts for packages that have anything to do with Flash on my system? So I can take pkg util packages and use the pipe character to pipe the output of that to grep. So I'm telling grep to search the output of pkg util packages for anything that has the word Flash in it. And the -I means case insensitive. That's why it found both Flash with a capital F in that first package and Flash with a lowercase f in that second package. So I do that a lot. I'm looking for something, I don't quite remember the name, quite remember how I spelled it. So piping something to grep -I filters it in a case insensitive way. There's pkg util -- package info, and that will give me more information about a specific package. So I saw that in that last slide. I saw that com.google code monkey disable flash, and I didn't really remember what was that all about. I don't remember what was that. What is that package for? What did it do? So if I get package info on it, I can find out where it's installed, and I can find out the install time. And okay, that install time is just a number. What is that number? It's the number of seconds since January 1st, 1970, at midnight. So everybody can do that math in their head, right? You know exactly when this is. Well, you can just ask date. So date -r, give it that stupid number, and it will spit out a date that at least is readable to people in the United States. So that was installed a few years ago, but I still don't really remember what that package was for. So I can ask package util, hey, can you tell me the files that were installed by this particular package? And, okay. So this is starting to ring a bell. Does anybody here manage Flash settings at all? Does that file look familiar to you at all? Yeah. So Adobe does document ways you can manage certain parts of the Flash player, turning off the auto updater. There's other things that you can set, and all of those settings go into this file, this mms.config file. So now I remembered I built a package that set that file so that I could turn off the Flash auto updater, because I'm using Monkey to keep Flash up to date. I'm not letting Flash's auto updater do it. So I turned that part off. I can also flip the idea. So with package info or package util file info, I knew which package I had, and I wanted to find out what files it installed. But maybe I'm going the other direction, which is I have the file, it's sitting out there on disk. I can't remember how that file got there. So I can ask package util, do you know anything about this file? And it tells me that, yeah, that file was installed by a package called com.google code monkey disable flash, and tells me when and all that sort of thing. So there may be, you see a file that's appeared on your users' machines, and you don't know how it got there, and you want to trace it back to a vendor installer. This would be one way to do that. Package util -- forget. Don't we all want to forget Flash Player? That simply removes all of that data from package util's database. Something you might want to do after you've manually removed something, you want to just get rid of that information. Because if I were to manually delete Flash, this receipt would still be sitting in the package util database. Maybe I want to get rid of it after I've manually deleted Flash. And there's more commands. These operate specifically on actual packages. We looked at the expand command earlier, which we can use to take a flat package and expand it out into a directory of files. Here I've expanded a Wacom driver package so I can dig into it. Flatten is the opposite. I've expanded this package into its component files. Now I can reflatten it back into. Why might you want to do that? Well, maybe you're fixing a package, you've expanded it, you've deleted something out of it that shouldn't be there, or fixed a typo in one of the scripts or something like that. You would then use flatten to turn it back into a usable package. That has some caveats, like if it's a signed package, you're going to lose the fact that it's signed. And you've now gone down the road of altering vendor packages, but it is something you can do. Package util -- bomb extracts just the bomb files out of a package, and then you could then use lsbomb to read them. That's how you would get more detailed information about the contents. Payload files just gives you the actual files, whereas if you do the bomb stuff, there we go. If you do the bomb stuff, you can actually get additional detail like the owner, group, mode, that sort of thing. Rather than just the strings or the file paths. I mentioned very briefly that packages can be signed, which will let you be sure that the package hasn't been tampered with since the developer created it. You can check the signature before you install it to see if it's valid. So let's do a quick little exercise using pkg util. Can you answer these questions? How many packages are installed on your machine? And remember I showed you could use pkg util -- packages to get a list. So just get that list and start counting. So if you're a little bit more Unix experienced, maybe you know there's a way to count the lines of output. A hint I'll give you is you might look at the command wc, but maybe what you want to do is output that list and pipe it to wc and see if it will count for you how many lines of output there are. That will at least roughly give you an idea how many packages are installed on your machine. What packages are responsible for the current contents of these files? That might be the package util -- file info. And what files do the xprotect plist config data packages manage? Let's look at that first one. So how many packages are installed on your machine? Anybody figure that out? I heard Pam say something.
I actually don't understand the output.
Let me give you one more hint. You're already piping it to wc, right? Let's give wc one more flag, -l. And then that will limit its output to only the number of lines. 165. So Pam has 165 packages. Anybody got more? 548. More than 548? 631. Anybody got more than that? 976. Anybody got more than that? 1633. That's pretty good. I think I can beat you all. Let's see.
I think we should have a pool first.
You think we should have a pool? Like if I don't have more, I have to pay some money? pkg util packages wc-l, or not one, L. So I'm piping this to wc, telling it to count the output, but just give me the number of lines. 1934. At previous workshops, I've seen people with over 2,000. So you're thinking, why the hell are there so many packages? Well, we can find out. Let's pipe that to, not Greg, because what? Why is it not winning? It's losing that I have this many packages, yeah. Okay, there's a lot. Let's find out how many that is. I'm going to take that. So 1,400 of those are Microsoft packages. Yeah? And lest you think I have lots and lots of different Microsoft things installed, let's narrow that down to Microsoft Office. So 14, right? It turns out that every single Office update spews another 30 or 40 package receipts onto your machine. Maybe it's even more than that. I actually haven't done the math to figure it out. But if if I scroll up here on this, just one sub-package, which is this com.microsoft.office.en word wizards, I have no idea even what this package does. Well, I mean, look at how many varieties of it are on my machine. 1401, 1439, 1441, 1442. It's crazy. There's a lot of receipts. Who has the least number of receipts on their machine? What was the lowest? You said you had 165. Has anybody got less than that? 20? Did you just read? Wait a minute, you're cheating. That's not even a Mac. What?
I had 126 and I'm not cheating.
126, okay, good. 80 something? 88? 60? Did you just re-image your machine yesterday?
I just started using it.
Yeah. So when you do a fresh install of OS 10, yeah, you'll probably have the number of packages will probably be in the double digits, somewhere between 50 and 100. And as you install more and more software, that number. And if you install Office 2011 and update it over a period of years, you're going to have, 15, 1,600 package receipts on your machine. All right. Well, we did that. Well, you can do that for yourself if you want to find out how many Microsoft packages are on your machine, right? Now, I only picked these files because they're pretty much guaranteed to be on everybody's machine, but if you're like, how the heck did chess get installed on my machine? This is how would you find that out? Does anybody remember how you would use pkg util to find out what package is responsible for chess? So it'd be pkg util -- file-info, and then the path to the file is of interest. So if somebody found out what package is responsible for chess, I'll give you a few seconds here. Yes. com.apple.package.essentials is what you said, Sarah, right? So chess is an essential, right?
Do you have to do that all the way into the contents package?
You don't.
Do it in the app?
You could probably get away with just doing it for application/chess.app. It would probably find it. That's not a file, it's a directory, but it would still probably find it. Yeah. The trick is that I don't know if you put a slash at the end, it's not going to find it, I think, or it's the other way around. So you have to format it exactly correctly, because it's very literal about what it looks for. And I think if you do it with it, okay, that's good. I think in older versions of OS, you had to be really particular about it. So that's why I was pointing to a specific file rather than a directory. And you can do the same thing for Safari and find out. With Safari, if you've had your machine for more than a short amount of time, you'll actually find that there's probably multiple packages that have touched that. So it would be whatever that was installed with the original OS, and then any update packages that may have updated that file over time. This one's a little trickier. What files are managed by the xprotect plist config data packages? So there's two tasks here. First, we have to find the package IDs that are for the protect plist config data packages. So one way to do that would be to use pkg util -- packages and grep for, say, xprotect. And that might look a little something like that. And you won't necessarily see that exact same list of package receipts, but you'll see something similar. And then once we have some package IDs, we can use package util -- files to query what files are installed by one of those package IDs. And that might look a little something like that. So now we can see what files are managed by that particular package. Does everybody know what xprotect? Is everybody familiar with that? I've heard of it before. It's one of Apple's malware solutions, or anti-malware solutions, I guess is a better way to say it. So that was pkg util. Let's look at pkg build. How much time we got here? All right. No, we have to go on and on. The slides will come. pkg build. This is a command line tool that we can use to build packages. And we're going to build a simple package to cause a policy banner to display over the login window. And to do that, we need to install a single file, library security policy banner.rtf. And you can create this file using, say, TextEdit. I went out to the internet and found a sample acceptable use policy, and I copied that into a text file. And it goes on and on and on. It's like pages and pages of all of the stuff that these poor users must agree to. But I've got that file sitting out on my desktop. And so I want to start using package build to build a package to install it. So I need some working space. I'll create a folder on my desktop. First I'll change directory to my desktop, and then I'll create a folder. I'm going to just call it Policy Banner. I'm going to create some folders inside that Policy Banner folder. And what I'm doing is I'm creating that folder structure. Since I need to install this file in library security, I need to have that path exist inside my working space. And so if I were to look at that in the Finder, on the desktop, I've got a folder called Policy Banner. Inside it is a folder called Library. Inside it is a folder called Security. And then my next step is I could either drag the Policy Banner RTF into that security folder, or I could use the terminal and copy it, or I guess I could have also used MV to move that, or to copy that Policy Banner into the correct subfolder. And again, in the Finder, it would look like this. So Policy Banner, Library, Security, policybanner.rtf. So the top level Policy Banner, think of that as a placeholder for Macintosh HD or whatever the name of the disk is that you're installing to. And what we've done is created a folder structure underneath that mimics where this file is going to end up on the target disk. Now we can use pkg build to make that package. And all of this command could be on one single long line, but I've broken it into multiple lines to make it a little bit easier to read, and that's what the backslashes are. That's where I've broken to the subsequent line. But you could type it all as a single line, just leave those backslashes out. So the first option to package build -- root, I'm telling it what folder to use as the root of this directory system. So that Policy Banner folder that we created that contains library, security, and then the RTF file is in Policy Banner. I'm giving it a name. That's the identifier. And this should be unique. For this demo, it's edu.psumac.demo.policybanner. Version, this is the first one we've done. So this is version 1.0. And the last thing is, what's the name of the package that we're outputting? When you create this package, what should it be called? Policybanner.pkg. Hit return. Package build tells me it did exactly what I told it to do. And if I look out on the Finder, I can see there is now a policybanner.pkg on my desktop.
Is there any magic to the com file?
No. So I think what Pam was asking, is there any magic to that identifier? Is that what you're asking? That's just a unique name. What I recommend is, for your organization, if like for me, I work for Disney Animation. And so any package that I make starts with com.disneyAnimation and then some sort of unique name past that. That ensures that, if you make a policy banner package and I make a policy banner package, they're going to have different IDs because you're probably not going to use com.disneyAnimation as part of your package identifier string. You want to try to make them as unique as possible, and that's a strategy that helps you do that. But you could just, they don't have to follow that format. That's just a recommended format for them. Yes?
Quick question. When you do that as part of your normal structure, and you put in that identified Disney Animation Studios, is that case sensitive?
Yes. Yeah. Package identifiers are case sensitive. So we're going to check our work. We can use something we learned just a little bit ago, pkg util payload files, policybanner.package, and it shows us exactly what we put in, which was that directory structure. We can get fancier. But once we install this package and we log out, we'll see something like this. And I was going to do a short demo, but time is short, so we're not. We're going to move on. Package build, you can also very quickly and easily build a package from a drag and drop application. Firefox would be a good example. We don't have to do all that stuff about creating a root directory, though we could. I mean, I could just have created a Firefox/applications and then copied Firefox into that. But there's a little bit of a shortcut in that you can point directly to this. So I'm just saying, use this component that's out here on the on this Firefox disk image, volumes Firefox, Firefox.app. I want it installed to /applications. And notice I didn't give it a package identifier, and I did not give it a version. What's going to happen? Well, if I do that, I do get a package on the desktop called Firefox package. I can use pkg util to check the work. It looks like it's what I expect. It's Firefox app and a bunch of stuff inside it. I can expand it out, and I can look in that package info file that's in there, and I see it picked an identifier, and it picked a version. So where did those come from? Does anybody have a guess where that identifier and where that version came from? Yes, sir?
Grab it from the app.
Sarah says that did it grab it from the app? That's absolutely what it did. The app itself has a bundle identifier, which happens to be org.mozilla.firefox. And that app's version was 47.0. So it gets that for you. So you don't have to be consistent about that. You can just let package util figure it out, or package build figure it out for you. So as I said a couple times earlier, an archive contains information about location, kind, owner, group, mode of each file and directory. And we haven't specified those. Package build has a flag called ownership, which can take 3 values. Recommended is the default value. So this is what package build will do by default. And it applies Apple's recommended owner and group to files in the payload. And generally that means it's going to be owned by root, the group is going to be wheel, and the rights are going to be read, write, execute for the owner, and we're going to take away write rights for group and actually scratch that. It doesn't have anything to do with the rights, just the owner and the group. We'll talk about rights in a second. Preserve uses whatever the owner and group is that's on the disk. So if you're building a package and certain files have to have a very specific owner and group that's not root, this is how you tell it to pay attention to what I put on the disk in terms of owner and group. And then there's another one which I've never used called preserve other, and it will pay attention to the owner and group only if it's different than the current user. So if there are files in the archive that are owned by root or by user 501, it'll pay attention to that. But any ones that are owned by me, by Greg, it will switch those over to being owned by root in the package. So that was owner and group. The mode is always taken, in other words, the mode or the rights or the permissions is always taken from the actual files on disk. So if those files need to have a special set of permissions, you need to set those permissions on those files before you build the package. And this is how we avoid the post-flight script that fixes owner, group, and mode after the fact. Just make sure the files have the correct stuff before you build the package. We are going to skip the exercise. And I want to move on to product build, which is yet another tool that you will find installed by default. And it builds distribution style packages. It's also, if you're building stuff for the App Store, you have to use this tool. For our use, our main thing that we're going to use it for is to convert a component style package that we built using package build into a distribution style package. Or we will use it to combine multiple component packages into a single distribution package. So in this case here, I'm going to the desktop, and I'm going to convert a Firefox package that I built as a component package into a distribution package. And all I do is give it the component package as an input package, Firefox package, and the output is Firefox-dist package. And if I would then use package util expand, I can see that inside that package, I get the distribution file and Firefox.package. More useful would be to combine multiple component packages. Let's say you wanted to have a single package that installed Chrome and Firefox, or installed Flash and a configuration package that turns off the auto updater, and you didn't want the techs or your users to have to install multiple packages in the correct order. You wanted them to install a single thing. You can combine those component packages using product build, and I just give it multiple input packages and a single output package. So here I've combined Firefox package and the policy banner package into a combo package. It will put them in the distribution file in that order, yes. At least that's been my experience. Yes, it's very similar to a meta package. It's the flat package version of a meta package. So if we can check our work here. We can expand the combo package, and if we list the contents, we see that there's the distribution file and the two sub packages inside that package. And we're going to skip the product build exercise because I want to make sure we have time to get to hello. Package scripting. By now, this should be seared into your brain that a package is an archive of files and directories, and that it may also optionally run some scripts. So let's look at some scripts in packages. Bundle style packages, again, they're often inside the resources directory. There can be 6 different kinds of scripts in a bundle package. A flat component package, there's a scripts directory inside it. We get rid of 4 of those types of scripts. So all we have to worry about is pre-install and post-install. This is something that a lot of vendors get wrong. Any script that the installer runs as part of a package is sent certain additional data that it can use. It's sent the path to the installation package, but most importantly, the one that we're going to use a lot is this number 3, $3. It's the target. So a package isn't always being installed to the current startup disk. Sometimes you install a package to a different disk. For example, if you're booting from a NetBoot set and you're using Deploy Studio and you're installing a package while you're booted from Deploy Studio, you're not installing it into the current startup disk, you're installing it into the volume that you're imaging or the volume that you're setting up. That's not the current target disk, or that's not the current OS disk. And there's some additional environment variables that are available in the scripts. I just want you to know about these. We're not going to go into detail. So let's look at a really simple post-flight script and see how easy it is to do it badly. So I'm building a package that is going to suppress the setup assistant at first launch. And the way that can be done is by making sure these 2 files exist on the startup volume. private var db apple setup done, library receipts setup reg complete. First problem with this script. I mean, this looks pretty straightforward. I ran it on my machine and it worked, so it must be good. But the scenario where I'm using, say, Deploy Studio, if this script is being actually used to install a package on my target volume, what's going to happen here? It's going to try to create these files on the net boot image, the thing that I've booted from. You don't have to bend down. This thing is so high. I mean, you're taller than me, but you're not that tall. I mean, I don't think Shaq would cast a shadow high enough for that. Okay. Well, okay. So we want to make sure that this package will actually try to create these files on the correct target disk. So we know that if we add that $3 contains the path to the current target disk. So we throw that at the front of these, and so now instead of touching a file on the current startup disk, it's going to touch it on the correct target disk. And so this is going to be right. Is there any problem here? Has anybody ever seen a disk named Macintosh Space HD? Has anybody ever seen that? I don't think those are very common, but no, every single machine I've ever seen ships that way, right? So there's a space in the volume name. So what's going to happen here? It's going to try to touch volumes Macintosh, and then it's going to try to touch HD / blah, 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 blah. It's going to try to do two separate. So it's going to do the wrong thing. So how do we fix that? Put quotes. Okay, so I fired up TextEdit, and I put quotes around the script. Anybody see anything wrong? They're curly quotes, because that's what TextEdit put in there for me. And this is going to barf, right? Okay, so now I fix that. I go back and I put my straight quotes in instead. Package scripts run as under what user? Root. They don't run under your account. They run as root. What is touch? Other than some magic thing that people tell you to type? It's a command. It's a command that actually exists on disk. How does the shell know where to find it? You have a command path or a set of paths that the shell searches. Do we know what root's path is? So if I just say touch, it might find the right command for me. So we really, for robustness, we probably should specify the full path. So we really should say the touch command lives under user bin, so we should really say user bin touch, make sure the path is quoted, make sure we put the $3 in there to target the correct volume. And did you see how much work we had to do to make sure a 2-line script operated correctly in a package post-flight? So when you see a 200-line post-flight script from some of our favorite software vendors, what are the odds that every one of those lines is correct? So a package, again, is an archive of files and directories. Why did that exit? Oh, because the AT Wi-Fi wants me to connect to them. Don't use a script when a payload will work. I did all that work trying to get the stupid script to create 2 files for me, but that's what packages do. Packages can install files. So instead of laboriously trying to get this script correct, this simple script that's just touching 2 files, but I still made a ton of mistakes, I should just create the payload that has those 2 files and let installer do it. An installer will target the correct volume, and an installer won't be confused by spaces in the volume name and that sort of thing. So let's look at a few common scripting errors we see. And man, I got to fly here. Again, forgetting to refer to the target volume. I won't say any names here about major vendors who make mistakes like this, but they do. Interacting with the Finder or doc. If you're pushing out software to your users, if I'm a vendor and a user installs my software, I might put in this thing so that the Finder opens up with a window showing them where this software I just installed, where it is, so that way they can start using it right away. But if you're pushing this software out silently to users, do you want that? You know, you're pushing out an application and they're busy, you know, typing an email, and then suddenly this window opens up with the brand new software you just installed. That's not good. That's not good usage. And you'll see stuff like that. You'll see references to the Finder, to the dock, or calling AppleScript to do various things in a post-flight script, assuming that there's any user at all. I mean, this is a post-flight script that tries really hard to change the owner of a preferences pane to whatever it thinks the current GUI user is, and to add a login item for that user. Well, what happens if it was a tech that just installed this software, but now the next user, the real user of the machine, logs in and this login item hasn't even been installed for them? Or what happens if you'd installed this automatically via Monkey or ARD and the machine's sitting at the login window and there is no GUI user, this login item doesn't get installed at all? And lots of other assumptions about the environment. And one of my other favorite ones is Adobe Reader, which for whatever reason as part of its pre-flight wants to move the current version of Adobe Reader into the current user's trash. Well, what if there is no current user? It's sitting at the login window, there's no trash for it to move it to, the script fails, the install fails, and you can't figure out why it's not updating Reader. So let's do a concrete example in our time remaining. We want to make a package that runs a script that turns off Bluetooth. And again, I've got a very simple script here. I know that if I use defaults, I can turn the controller power state for com.apple.bluetooth off by writing a 0 there. And then I need to kill the Bluetooth daemon for it to pay attention to that preference change that I just made. But because I'm going to be using this as a package script, I need to make the script a little bit more robust. I need to use that $3 to make sure I'm targeting the correct volume. And I don't want to kill the Bluetooth daemon if I'm installing it on a different disk. I only want to kill the Bluetooth daemon if I'm installing it on the current disk. Because if I'm installing it on a different disk, there's no Bluetooth daemon running on that. It'll be fine. It'll read those preferences when it launches. So I can take that script. I've got it in a text editor. I'll save it as post install in a scripts directory. I need to set the executable bit on it. Otherwise, package build won't recognize it as being a valid script. And then I can use package build with a couple new flags that I haven't shown you yet. There's no payload for this package. It's not installing any files. It's only running scripts. I'm pointing it to the scripts folder that I created that had that script. I'm giving it an identifier, PSU Mac demo Bluetooth config. It writes the package for me. And I have a little, let's see if I can demo this quickly. I pre-baked a package. Let's bring it over. So this Bluetooth package. And we can see, let me zoom in a little bit. So everybody can see the Bluetooth icon here, right? All right, let's open up this package. It's probably going to open on the wrong monitor. There we go. So obviously this isn't something you would have the user install themselves. This is something you would install in the background with software management. So continue. Again, keep your eyes right here. Install. Yes, this needs. Look, it went. Okay. So I've built a package that can turn off Bluetooth. And yes, AT&T Wi-Fi. Thank you for your. I don't want you. All right. So I have some recommendations about scripting. My first and most important recommendation is don't script. A script that doesn't exist has no bugs. Don't use a script to fix mistakes in a payload. Make sure you use $3 in your scripts to so that you're targeting files on the target volume and not on the startup disk. Don't forget the target volume name might have spaces, so you better quote that thing. Test via the command line. Don't assume that this is going to always be installed by somebody double-clicking. Make sure you test installing to something other than the current startup disk. Make sure you test installing at the logged in window. And we are out of time, so if you have questions for me, I'll be around. There's actually half an hour till the next session. I'll make myself available at least for the next 15 minutes if you've got some questions. Thank you, everyone.